All right. I hope everyone can hear me. Okay, so as Louis said, I'm going to talk about Python packaging. Why don't you just? I intended for this talk to be an introduction for unique things in Python packaging, but I just had a conversation with a bunch of people just like an hour ago about how we don't know, and everything we think is unique is actually not. So I guess I'll just pivot this talk to into an experience for me to learn what others are doing the same thing as Python packaging instead. So a bit about myself. Just call me TP because my name is impossible to pronounce unless you speak Chinese. I live in Taipei, Taiwan, and we're currently working for Astronomer on Apache Airflow and also a contributor and volunteer for Python packaging as a member of PyPA and other stuff. So Python packaging. Uh, Everyone loves to hate Python packaging because it's like not doing a lot of things very well. And they like to say that we're like sort of incompetent or doing things wrong or have bad ideas about about packaging. But I don't think that's very fair because Python has a lot of like backward compatibility and other stuff to deal with. So what I'm going to do today is I'm going to introduce you some topics that Python packaging is somewhat unique on, and I'm going to break those down into what was the use case Python was going to solve, and why did Python decide to go with the solution it does, what disadvantage does that solution bring, and can we overcome the disadvantage without breaking our original use case. Okay, so here are the topics I'm going to talk about. First one, we introduced a new resolver in pip like about 2 years ago right now. And a lot of people have come to complain that pip needs to download way too much data to resolve to do dependency resolution. And for example, sometimes you need to like backtrack 5 versions of TensorFlow, and each TensorFlow is like 500 megabytes, so you end up wasting more than 2 gigabytes. Yeah, that's not very optimal, but in order to solve that, first we need to like go back to figure out why this is the case. So the main reason why pip needs to download all those data is because the dependency metadata of, say, TensorFlow is only available in that exact artifact of TensorFlow package. Okay, and the reason to that is actually pretty simple because Python packaging predates a lot to the concept of a package installer. And before package installer was a thing, you need to literally download artifacts from the internet, and the easiest way to distribute those artifacts is as a single tarball or zipball, right? And when Python standardized the interchange format for packages, it just went on to use that single tarball as the standard format. We call it asdist. And what makes things worse, the de facto like build script is in Python. And Python as a dynamic language can do literally everything. It's a proper programming language. So when pip downloads a package, it has no other choice but to download the full package and run the build script in order to obtain dependency information. And it has to download the whole package because it doesn't know what information the build script needs to get dependency metadata. And this is what we end up with. Like, right, for TensorFlow 2.6.1, we have a bunch of binaries, and those binaries are built from that build script. And because those are built from the build script, those binaries may end up having different metadata for all of them, even though they are all TensorFlow 2.6.1. Okay, so that's a problem. But there are also advantages to that function, I guess. Distributing Python packages is one of the simplest among ecosystems I've seen. We just talked about how metadata was like distributed in package managers in the panel in the previous session, and Python was doing how Python does things is doing like exactly the things that some people don't like. We do ad hoc requests to all the things, but this also has a very nice property that we have the simplest package index protocol you can possibly imagine. You can literally just run an FTP server and call it a day, or even you don't need a server at all. You just need a network drive and put some files on it and share among the organization. This oops, sorry. And this makes distributing Python packages extremely easy. So we don't want to break that. We still want our very simple file server system thing. So how we plan to improve the situation is that, one, for binaries, or in Python land we call them wheels, we mandate static metadata, and they need to be built from that build script, pre-built from that build script. So when pip downloads metadata, it knows exactly what dependencies it wants. So it at least limits the thing pip needs to do. It only needs to download that one file if it's dealing with a binary. Okay. And we also introduced an optional feature that nobody currently implements, is that even if you're distributing source, you can also use the same metadata formats to say, I have static metadata, please don't run the build scripts. Okay. And we also, another thing we do is we extended the API for package distribution to also serve that single metadata file as an entry on that server. So if you remember that HTML file I showed you, there will be one additional link for everything just for metadata. So an installer can use that file if it finds it, and if it doesn't, it just fall back to download the whole package and extract the metadata file. Okay, so we just talked about binaries, and that's another complaint for people. So Python has been offering binaries for quite a while, and a lot of Python users depend on it because they are pretty convenient, and people tend to don't know how to build stuff. If you write Python for long enough, you forget that tribal knowledge. But sometimes binaries are just not available. For example, Python 3.10 was released last month, and I think most of the packages out there, including very popular ones, still don't have 3.10 wheels, and you need to build from source if you happen to just upgrade it to 3.10. Why is that? Like PyPI has a lot of funding. Why don't we just automatically build those before we release 3.10? Well, yeah, we have a lot of funding, but the funding is still not enough because it's already extremely expensive to distribute all those files on PyPI. We just don't have enough resource to do all those additional builds and the infrastructure needed for that. But there are also technical reasons, which I call infinite wheelhouse paradox, named after the infinite hotel problem. Like in an infinite hotel, even if your hotel is full, you can still have a new guest because infinite plus one is still infinite. For Python, you always have a platform not covered by your wheels, because you can always come up with a new platform that is like not defined previously. The main the reason for that is Python does not have the concept of support tiers. Basically, any platform that builds Python, it's considered supported, and the supported platform expect to be able to use the packaging system. And some of those environments are very obscure, and I'm not going to name names. And some are not obscure but have interesting properties. For example, Android does not do threading like how you would normally do on POSIX systems. So you basically end up with a bunch of like different long tail, a giant long tail of platforms you need to endlessly try to support. This sounds pretty awful, but also a good problem to have, because this allows Python to be run literally anywhere, including on circuit boards. So we still want to continue to be able to do that. So instead, the solution we come up for that problem is that instead of declaring what real world systems we want to support, for example, Windows, we don't say we support Windows, but we come up with an abstract definition of what a system would look like. For example, like for Windows, we would define the Windows platform based on the Windows API version. And for Linux, we would look at things like libc, glibc presence, or like pthreads and versions of common libraries, and define and a system can choose to opt into one of the definitions we provide to say, hey, I declare I conform to this definition, and we would pull a fitting wheel for that. Now, this solves one of the half of the problem. The other half of the problem is, how do we come up with a common set of definitions that people would probably use? And this has been a big problem for us for quite a long time. But recently, because we have more like pervasive CI availability, in particular GitHub Action and Travis CI up until recently, we have kind of a sense of what people commonly need, which are the platforms the CI platform provides. So we recently adopted a new tool called CI Build Wheel, which basically runs on your CI to build wheels. And you can define whatever platform you want to support with CI definition, and we'll just build one wheel for each CI, what's that called? For each entry in the CI matrix you have. And this kind of externalize the wheel building stuff from Python packaging to the CI providers. Okay, so now you have your package installed. How does pip find your package? And sometimes you can even like, why does pip find this old version of the package instead of that new one I installed somewhere else? It's also kind of wonky. So first we need to talk about how Python, the base interpreter, not Python packaging, manage packages, or how it actually doesn't. Python packages are, you probably already know, they're just files. So for a long time, Python packaging tools does not have a way to uninstall anything, because they're just files, and we don't know what are installed where. So at some point, setup tools came up with an idea. So instead of just installing files, we would zip all the files, put in some metadata to list the files, like, because it's a zip, it knows what files it contains. And when on installation, it will put that zip on disk and like point the import system to use that zip instead of directories. But the problem is that a lot of the packages doesn't actually work that great. But they should, because Python supports that natively, but they're not written good enough. They may probably sometimes contain relative paths that doesn't work well inside a zip file, and they probably want to write into their own directory, which you cannot do in a zip. So eventually we just got rid of that zip and end up with just directories. So, okay, so now metadata in Python are just files. And installing a package just means that in addition to whatever source code you've written in Python, or the external extension modules you compile from C or things like that, pip would also install a bunch of extra files that logically counts as a part of that package onto into your environment, and put it alongside of the importable package. But some people kind of take issue with that, but I don't think there's a problem. Like reading plain files is just nice, right? It's much easier than maintaining a database. And by putting the importable code and metadata side by side, we end up being able to reuse the same logic to import packages and to find metadata, which is like conceptually easier to understand and maintain. Okay, so I've went through my topics, and at this point you might start to think that, okay, this all makes sense, but let's take a step back. If you like look at the whole thing, you would say that, wait, this still does not kind of make sense. Shouldn't you at some point just like, no, this is just bad, we should reinvent the world and do it all over again? And you're kind of right. Probably we should, but I don't know. Again, we need to take a step back and look into the history. So Python packaging is right now, I'm calling it the third system effect. So the first ever Python packaging system is called distutils. It's a standard lib module, and it has a very, very long and winding history and kind of works okay when it was first introduced, considering the what the best practices were at the time. But packaging paradigms change and people start to invent new things on it. And at one point, people started to think that distutils sucks and we should just rewrite everything. And it was codenamed distutils 2. And the scope was very big. We have very grand visions, and that did not work out. That's the second system effects people are more like familiar with. That just failed, and people just dropped off because things don't work out. And this is when PyPI came in. PyPI was introduced to take over some of the abandoned projects from those contributors. And by the time we came about to try to improve the situation, we don't want to fall into that same problem again. So we decided to do things more iteratively and consider and instead of like rewriting the whole world, we want to, like, for every step we take, we want to first check whether all the existing things are working properly, and we properly standardize those before we build new standards on it. And after the standard is made, we can actually implement the standard. This is like from PIP to PEPs. Like PEP is Python Enhancement Proposal, which is a proposal to enhance Python. And there are two parts to achieving this. First, we need to set up rules so new implementers don't need to copy paste existing tools, like feature by feature and bug by bug, more importantly. Instead, we make new implementers follow those standards, those PEPs. And if the standards and the behavior of an existing tool disagree, we need to fix the existing tool. So the standard becomes the canonical information instead of the implementation defined behavior of existing tools. Second, we need to build libraries for those common things, common standards. Traditionally, packaging tools are mostly monoliths. So new tools either need to rely on private API or straight out just copy pasting code, which is bad for a lot of reasons. So we want to break down those things into smaller pieces that people can reuse. So this is Python packaging. I think at a Python I didn't attend, it's proposed that Python packaging should have a mascot. And the platypus seems like a perfect choice. It's weird to look at, but everything makes sense and is needed because evolution. It's super important to remember the lineage, not instead of complaining why things are bad, we need to remember why things are done this way and carry that knowledge forward with us when we try to improve things. All right, that's all I have. These are the platypus. Thank you. Luis, I can't hear you.
Oh, sorry. Hi. Can you hear me? Thank you.
Yeah.
I thank you for your presentation. I don't see questions coming in YouTube or Element yet, but
Yeah, I think the
fine.
obligatory XKCD.
Yeah, I've been a long time Python user, and I saw a lot of this history unfolding. I have a lot of appreciation for anyone that tries to solve this problem because it's a really hard problem.
I'm sorry.
One question. Let's okay. Let me copy this one here. So, what are your predictions on the main changes coming, if any, for Python packaging?
Predictions. Well, I only know what I know, so there are two kind of things I can say. Like we are still planning. We're always planning new things, so I can not really saying. Instead of making predictions, I can like spoil you to some like spoilers of what's going to happen. So we're trying to catch up on some of the like more common things on packaging. For example, lock file, like something like cargo.lock, and something like what's that? The package.json in npm, and have a workflow more akin to like npm and cargo. And we already have some experience on this. Poetry is a pretty popular one. And the thing we're trying to do, as I said before, we're trying to standardize all those things so we can have like a better foundation to build on instead of like fragmenting everywhere. And beyond that, I'm not really sure. I think we should do something about security. Like Dustin made a talk yesterday about the supply chain attacks, which is a very important problem in Python. Right. We mentioned that in the panel as well, and I think we're going to do something about that.
Cool. Yeah. So we have another question. What's the most difficult part of your third system in real world?
Most difficult. Everything is difficult because you need to care about backward compatibility. Backward compatibility in general. Like the third system needs to be compatible with the first system, which is pretty outdated, and we need to keep those working. Yeah.
And maybe a follow-up for that question, what is your least favorite feature about PyPI that you would change if not for legacy?
Setup tools. Right. I want to just rip out setup tools and the binary, not the binary, like how setup tools finds compilers. Yeah.
There is another question here I will ask while I copy it. Do you see third-party tools like Poetry becoming more dominant and replacing older tools like Pip that don't suffer from backward compatibility constraints?
In a sense, no, because I think that it's the other way around. That Poetry user would eventually want Poetry to support old stuff, because there are still a lot of packages that are like mature and not updated anymore that people still widely use, and they want Poetry to support that. So I don't think any new third party rule can escape that destiny. Yeah. But instead, we want to make, like, when Poetry comes to deal with this problem, we want to make this as easy as possible for them.
Cool. Thank you very much, TP. Our time is up. We will go for the next session.
Thank you, everyone.